those who have experience in learning finance subjects may find it a little bit boring, but I would request you to bear up with me because it has to be very simple so that everybody can understand. My worry is, like, say, I have been doing this for some time, these two topics to the students, and I have been preparing questions on these two topics to the final examination. My worry is, although I make it very simple as possible, but I see that performance at exams on the questions is not very good. Right? Performance is not very good. So that makes me a little bit worried, not little bit. It makes me highly worried because I've gone through the online answer scripts a few days ago, and I found that many students have got low marks on these two questions. I am not aware about the others. I didn't study that, but considering the questions that I have put, I noticed that the level of understanding of the students has been very low. So that worries me a lot. So I wish to tell you at the very beginning itself. So we will do it very slowly and try to understand as much as possible. If you are not in a position to understand or you find it difficult to understand, please stop me and ask. Right? Please stop me and ask. This is almost all calculations. Time value of money is about a calculation. So you just have to get it into your head, right? Get it into your head and then practice calculations. So for this purpose, we need to have the calculator ready with us, a scientific calculator. So if you depending on the model of your calculator, you can download from the internet the functions to carry out calculations for time value of money as well as the other calculations, right? So be ready with that, because I will not be able to help you individually with your calculator function because my calculator is different from your calculator, right? So have that in mind also, right? So in the meantime, if I can find any app that you can download on your telephone for the calculator, I will be able to share with you. I'm looking for one at the moment. So if I find it, I will try and share it with you so that it will make us easy, right? So since it's about 8:34, I think we can start the class. What I would talk to you about is called time value of money. We call it a core concept in financial management because every calculation or every now say you have learned the objective of finance. What was it? It was to maximize the value for the shareholder, right? Or we do it through the price. So how are we to do it? We are to do it by employing or investing in positive net present value projects, because value has to be created inside the firm. Value has to be created by every investment. So value creation is creating assets or creating value inside the firm. Has to be, like we say, what went out, what came in has to be greater than what went out. Then there will be a surplus or value created inside the firm from an investment. Say, for example, you invest 1 million in a project, and as cash inflows, you get 1,500,000. So there is value creation, right? There is value creation. So in calculating the value creation process, right, we have to identify the cash flows, inflows as well as outflows. So you are well aware that we cannot compare cash flows as they are. Say, for example, I make an investment of 1 million rupees today, and it will give me 2 million rupees after 1 year. So after 1 year, I get 2 million rupees. I compare it with today's 1 million and I say I have excess 1 million. Is not the correct way to assess the cash flows or assess the value creation process. So in that sense, you understand that to compare cash flows, if we are to compare money, it has to happen at the same point in time. Either it has to happen at the same point in time, or we have to convert the cash flows to one common point in time so that they are logically comparable. Logically comparable, right? So for this purpose, we have to learn some principles of converting cash flows to the present as well as converting cash flows to the future. Because cash flows occur at different time intervals and different points in time when it comes to an investment. So we have to manually put them in one point of time so that we can compare and come to a conclusion whether we have created value or not. Right. So depending on this, we decide whether to invest or not also, right? Okay, with that brief description, so a time value of money is considered as a core concept in financial management because from the time you learn time value of money, you will be using the time value concept in all the other lessons that we come across in the syllabus, right? Okay, so if I'm talking too fast, please let me know. I'm in the habit of, like it flows like a river. I just talk very fast. That's my nature. So if I'm talking too fast and you cannot follow me, please stop me, right? Please stop me. Don't feel bad. Yeah, by the way, I am Champa Rajapaksha. I'm sorry I couldn't introduce myself to you earlier. I'm Champa Rajapaksha, attached to the Department of Finance, SJP, right? Uh, yes, I'm with Professor Veerapon, and we will be myself, Professor Veerapon, and Dr. Anuradha will be conducting this series of lectures, right? So, yes. Objectives of the lesson. After completing this lesson, you should be able to understand the time value concept, calculate present and future values of any set of cash flows, and apply time value concept for decision making. Right. So we will be having small calculations, small case studies to see whether we can apply time value of money concept. Right. So first of all, we must understand what is time value. Right? What is time value? So time value of money. So when I normally teach my undergraduates, I would ask them, what if I offer you an ice cream today or next week? I'll give you 1,000 rupees to give. I eat ice cream at Baskin Robbins. You prefer it today or next week, right? So majority of them they tell me, okay, you give me today, right? So I will not ask, since you are adults, I will not offer you ice cream or money for ice cream. So what would you prefer? Money you have today or at a later date? What would be your answer? If I offer you, okay, I offer you 1,000 rupees to have a candy. Would you like it to have it today or next week? What would be your answer?
We like to have it today, madam.
Have it today. Yes. Any reason? Any reason?
Because today the amount of goods that we can buy for that rupees 1,000 is higher than the goods that we can buy for the same amount after 1 week.
Okay, that is one reason. Another reason? Oh my God, very unlikely. Okay, okay. Yeah. Sorry, Karan with the okay, okay. So any other reason? Yes. Any other reason?
Today, not
Sorry?
tomorrow. The needity tomorrow. The needity of money is today, not tomorrow. The need,
You need it today.
yes,
Why? Why?
because have some spends to do today, not tomorrow. Like if you want some money today,
Okay.
but we cannot spend in tomorrow, maybe the value of money will be depreciated.
Okay. Okay. Accepted. Any other reason?
Madam, sometimes today rupees 1,000 will be enough or sufficient to purchase one candy.
Okay.
But next week it won't.
Oh, okay. Yes. With the inflation. Yeah. Any other reason?
The satisfaction we get today will be higher
Than delay in consumption. Okay. Okay. Any other reason?
sometimes next week I don't have the interest to have an ice cream.
Okay. Any other reason? Yes. Nothing else. That's all. That's all you can think of. Hmm? That's all. Is it? No other reason at all. No. So you guys trust me 100%. Is it? You all trust me that I will not default next week. So people prefer today's money due to time preference of money. Now, why people prefer money today can be explained under three reasons. Right? Under three reasons, we can explain why people prefer money today. Because there are alternative uses of money. Say, for example, I give you 1,000 rupees to buy a candy. You don't want to buy a candy, but you can use it for another purpose, right? You can save it for next week, or you make an investment, right? You can do something else with that money, right? If you do not want to buy the candy, right? So alternative uses of money makes you or gives you the opportunity to use it for other purposes, enables you to, like, say, makes you prefer it today rather than at a later date. Okay, that is one reason. And the other thing is people in general prefer to consume early. As you all said, you will not feel like eating candy next week. You will want it to eat. Right? So the general behavior of people, human beings, is to consume early. So they would prefer to have it today rather than at a later date. And the third reason, which is the most important, is the risk associated with future cash flows. Now, I am so sweet today offering you 1,000 rupees each to buy a candy. And you all are very considerate about me. I'll say, okay, Sunday. And next Sunday, I come to class and I don't mention anything about it last week. Right? So you will not be able to get the money. So there is a risk associated with the future cash. So due to these three reasons, right? Due to these three reasons, people would want money today rather than at a delayed date, right? So you guys were so innocent, you all wanted to trust me, right? You all never thought that there will be a risk in the future cash. Right? So thank you for that. But remember this point, right? Risk associated with future cash flows. So due to these three reasons, people would want it today and not at a later date. And if you are to delay it, right? If you are to delay it, you will ask for a compensation for delay because there is a risk involved in the cash flows and you are delaying consumption, you are foregoing investment, and you are taking a risk, right? If you delay based on these three reasons, if you delay cash flows or you agree to delay cash flows means you are assuming risk of default, you are foregoing investment opportunity, and you are foregoing present consumption, right? So due to that, if you are to delay, you will always ask for a payment or a compensation for the delay, right? Compensation for the delay. So time value of money is the payment for the time preference for money. Right? Time value of money is the payment or the concession that you expect for the time preference of money. Right? So therefore, you may expect to get an extra cash amount as compensation for delaying because due to the delay, you may not get the cash flow, you may forego investment opportunities, you may forego present consumption. Right? So for these, you will ask for a compensation. Right? So it is also called the opportunity cost of money or interest. We simply call it interest. So if you say, for example, you get my 1,000 rupees today, put it in a bank, or whatever, or you give it on guinea poly to a friend of yours for 1 week, you will get a return, right? So that is, we loosely call it interest, right? So it is the opportunity cost or the interest, or it is the payment for the time preference for money, right? This interest for the time preference for money is called the time value of money. So we call it time value of money, right? So which implies that cash flows that occur at 2 points in time will not have the same value, right? Cash flows that occur at 2 points in time will not have the same value, right? So we discussed this. Yes. How to compare cash flows in different time periods. Investment projects generate cash flows in different time periods, and a rupee today is not equal to a rupee tomorrow, right? So, thus, cash flows in different time periods cannot be compared as they are, right? So, as I explained to you, we make an investment today, but the return comes in 1 month's time, or 2 months' time, or maybe 6 months' time, or in 1 year's time. So, we cannot compare that without any adjustment with the initial investment, because there is a time value for money, right? So in that case, we have to put cash flows to 1 point in time. Either, say for example, I make an investment today, my returns start 1 week, 1 year after. So either I bring all the future cash flows to today's value and compare with my initial investment, or else, say, for example, it's a single return investment. I make an investment today, I get my return after 1 year. Another thing that I can do is I convert this today's cash flow to future value, and then at that point we can compare, right? So there are two ways: convert to future value or convert to present value, right? Convert to future value or convert to present value. Right. So translate rupees 1 today into its equivalent to the in the future. Right? Translate rupees 1 today into its equivalent in the future is called the future value calculation, or you simply call it compounding. Right? We call it compounding. Or translate 1 rupee in the future to its equivalent today is called discounting. It's called discounting. Say, for example, um, I am supposed to receive a lump sum of money at the end of the year. End of the year. So if I want to know how much it would be value today, what I receive in December, what will be its value today? So I have to discount the figure and get today's value. Say, for example, I receive 100,000 today and I want to invest it for 1 year. If I want to know what will be the value of that investment after 1 year, what I would do is calculate the future value. It is called compounding, right? Discounting, compounding, calculating the present value is discounting. The future value is called compound. Okay. So timeline. We use a timeline for us to easily understand uh, cash flows and the timing, because timing is important, right? T equals today is normally taken as today, right? T equals 0 is taken as today. Now T equals 1 is after 1 year. T equals 2 is after 2 years. And T equals 3 is after 3 years, right? So you see in arrows, you start the year on after this thing, you start the year here, right? And spend the year right throughout, it becomes the completion of the year, right? So, when we address problems, we have to be told when the cash flow occurs, right? When the cash flow occurs, whether it's at the beginning or at the end. So if not specifically told, if in a problem or in a case, if we are not told specifically when the cash flow occurs, we always assume that the cash flows occur at the end of the year, right? So cash flow occur at the end of the year means after the completion of 1 year, after the completion of the second year, likewise, right? So in order to learn discounting and compounding, let's try to identify different types of cash flows. Now, in a firm, we get ourselves involved in investments. There can be investments which give you single cash flow, one single cash flow as return. You make an investment of 100,000. I invest it for 1 year. After the completion of the year, I get it as return, a lump sum of money, a sum of money as return of that investment. So it's a single cash flow project. Or else I may be making an investment today, but it will give me multiple cash flows. It will give me multiple cash flows, as I said. I make a 1 million investment today, and after 1 year, I get 100,000. In the second year, I get 200,000. In the third year, I get 50,000. In the fourth year, I get 150,000, and the project is over. Right? So it's a multiple cash flow. Then we are talking about multiple cash flows. Since the amounts are different uh, that we receive, we call it multiple uneven cash flows. Right? Multiple uneven cash flows. And there can be some projects that we receive the same amount of cash flow. Say, for example, I make an investment today of 1 million. After the first year, I get 50,000. Second year, I get 50,000. Third year, I get 50,000. Fourth year, I get 50,000. Fifth year, I get 50,000. Or sixth year, I get 50,000. Right? Say, for example, if you invest in a bond, the coupon rate is fixed. Right? Coupon rate is fixed. What you receive as interest is called coupon for a bond. So that is fixed. Generally fixed is you said 1,000 rupee face value bond paying 10% interest. So every year you will receive 10% out of 1,000, which is 100 rupees. So you will receive it until the maturity of that bond. So that is an even cash flow, equal cash flow received periodically. We use a special, we call it an annuity. We call it an annuity. And what is called a perpetuity? Now, say, for example, this bond doesn't have a maturity. Once you use, it goes on paying you interest periodically, right? And this flow of interest will flow in infinite future. There'll be no ending, right? It will flow into the infinite future for hundreds of years until the company is closed. It will flow, right? They will use your money and pay you interest forever. So that type of a cash flow is called cash flow. No maturity in the investment. You call it a perpetuity. If there is a maturity and you get a fixed payment, you call it a annuity, right? So these are the three kinds of cash flows that we come across in a firm, right? These are the three types of cash flows that we come across in a firm, right? So let's look at each one and see how to calculate future value and present value, right? How to calculate future value and present value, okay? Future value and compounding process. Future value is the total of the principal amount and the interest accumulated on the principal for a given period. It's the total of the principal amount that you invest in. Say, for example, I invest 100,000. It's the principal 100 plus the interest accumulated on that principal on 100,000. Say, for example, I have 100,000. I invest it at 10% for 1 year. So 100,000 out of that 10% is 10,000. So future value will be 110,000, right? So it's the sum which an initial amount of principal or present value. So today's value, present value, is expected to grow, over a given end period at a given interest rate, right? So at a given interest rate. So in our example, it was 100,000, 10%, and 1 year, right? So present value was 100,000, N was 10%, and N was 1, and R was 10%, right? So future value of an initial rupees 100 at 10% rate, right? Find the future value of rupees 100 after 1, 2, up to N years at 10% compound rate, right? At 10% compound rate. So how are we to do it? First year, today, see timeline, it's at time 0 today. After 1 year, it will be 110. And after 2 years, it will be 110 into 1.10. After 3 years, it will be that into again 1.10, isn't it? Right? So if we go like, and if we go like that, so let me do it for you so that you can, it will be clear for you. Yes, it's 100. So we have a present value. Present value is 100, right? Present value is 100. So we have R is 10%. R is 10%. Now we are supposed to find the value, right? We have a present value. Present value is 100, right? Present value is 100. And after 1 year, what happens? We multiply it by 110, right? Will give us the future value at time 1, right? After 1 year. So in the second year, what happens? We have the future value 1, right? Then we can multiply again it at 110, right? And we will have future value at time 2, right? Then what happens in the next year? We have future value at time 2. We multiply it again by 110, right? And we end up having future value of time 3, right? So at any point in time, you will see, right? So future value of 1, if we apply it here, say future value of 1 is, right? Present value into 1.1. Present value into 1.1. 10 into 1.10 will give you future value of 2. So if I apply it here, future value of 2, you will see. I can copy it. We can copy it and paste it here. Right? You paste it here. Right? So you will see if it is future value of 1, that is present value into 1.1 to the power 1. So if it is future value 2, it's going to be present value into 1.10. Sorry. What's happening? 0 to the power 2. To the power 2 equals the future value, right? Here, if we look at it, you see present value into 1.10, sorry, 1.10 to the power 3, right? Equals future value 3. So we can generalize it, right? Substituting the figures with n. So present value or future value at n will be present value into 1 plus r. Now in our case, it's 10%. We take it as r, make it common to the power n. Right? So it's a common formula that we can derive. Okay. So this is what is given here. So let present value equals PV, future value equals FVN. So R is equals to interest rate or compound rate per period. So future value at any point in time of a single sum of money is equals to its present value multiplied by 1 plus R, the interest rate, to the power n. How many years? If it is 1, future value of 1 equals present value into 1 plus R. If it is 2, present value into 1 plus R to the power 2. If it is 3, its present value into 1 plus r to the power t. So this is how I showed it, right? That's the proof of this formula. So this is something very easy to remember. Something very easy to remember in calculating future value, right? In calculating future value. So future value interest factor. Future value interest factor. Now this is called this 1 plus r to the power n. This is called future value interest factor. This is called future value interest factor. This is called future value interest factor. So future value interest factor at 10%. Say this is year, 0 indicates today, 1 after 1 year, 2 after 2 years, 3 after 3 years, etc. So if we invest 1 rupee today or on an annual basis, right? Say future value interest factor at 10% into n, right? This is how we write. Now, if it is today, it's in its today's value. So 1.1 to the power 0. So you all are aware that anything to the power 0 is 1, right? Anything to the power 0 is 1. So this 1.1 to the power 0 becomes 1. Multiply by the present value, it will give you 1. Present future value interest factor will be 1. Now, after 1 year, it becomes 1.1 to the power 1, right? 10%. N is 1, 1.1. So 1.1 multiplied by the present value of the principal amount 1 will give you 1.1, right? So future value interest factor for 2 years at 10% will be 1.1 to the power 2. Multiplied by the present value or the initial investment, it will give you 1.21, right? So this table, what can you observe from this table? What can you observe from this table? We have calculated it for 10 years. What can you observe from this table? Yes.
Madam, the future value is increasing with the passage of time?
Yes, exactly. With the passage of time, you have increased future value, right? Increased future value. So what can be the reason for that?
Due to the higher return?
One reason is that you get return on return also. One reason is that you get return on return. Now, second year, we compound 110, not 1. First year, you compound 1 into 10%. Second year, you compound 110 into 10%. Third year, you compound 1.21 into 10%, which since the interest is being added, it becomes larger. And the other is the time period. වෙලාවත් කාලයත් ඉක්මන් වෙනවා ඒ වගේම ඉන්ට්‍රස්ට් එක ප්‍රින්සිපල් එක එන්න ඇඩ් වෙනවා ඒ රීසන්ස් දෙක නිසාම තමයි ෆියුචර් වැලියු එක කාලයත් එක්ක ලොකු වෙන්නේ විශාල වෙන්නේ sorry it's because of interest on interest. It's one factor. And the other factor is it's the time, right? So that is how future value goes. So future value is always greater than present value, right? Future value is always greater than present value, right? That we have to remember. 3 ways to find future values. Solve the equations with the regular calculator, right? So as I told you, you have to have your calculators ready, scientific calculators if you have. You can use the calculator to calculate the future values. Or use a future value table. Now, this is a future value table. This is a future value table. So, if you go to any financial management book that we have recommended, all right, or we have not recommended, even this simple basic financial management by I.M. Pandey, if you go to the back pages of it, you will see a series of tables, right? Series of tables going up to about 50 years in terms of time, and it gives you interest rates up to about 25%, right? It's all calculated for you. So all what you have to do is choose it from the table. Now, say for example, now I would ask you, now what happens if you invest 100 rupees at 10% for 4 years? right? So all what you have to do is, okay, you choose the year 4. Now this is the factor is given for 1 rupee. So our present value is 100 and it is going to be there for 4 years. And we take this figure 1.46410 multiplied by 100, you get the future value. So if I ask you, what if I invest 1,000 rupees for 10 years at 10%, right? 1,000 rupees multiplied by this, you choose from the year 10, from the interest rate you choose 10, and then you find the figure and you multiply it by the principal amount or the present value. 2.59374 multiplied by 1,000 will give you the future value after 10 years. Right? So it's very easy to calculate if you have the table. That is one way. Right? Or the calculator or the table, or you can use Excel spreadsheets in calculating the future values and present values. I'm sure this will be covered by Professor Veerapon in your financial modeling class, right?
Madam,
Yes.
is it summation of interest and money we invest?
Yes, of course. Now, see, let's look at the definition. Let's look at the definition. I said at the very beginning, future value is the total of the principal amount and the interest accumulated on the principal for a given period. Understand? Okay. Yes. So these are the 3 ways. Now I give you an exercise. Okay. Now tell me, you can describe the graph. I have 4 lines. I have 4 lines: green, red, yellow, and pink. I'll call it pink, right? So, and I have these are drawn for 4 different interest rates, right? On the vertical axis, I have the future value factor, and now you know what is future value factor now, right? This is future value factor, right? Future value factor. And on the horizontal axis, we have time. Time in terms of years, let's say 5 years, 10 years, 15 years, right? This is interest rate or the future value factor, right? Interest rate, time, and future value. So please explain the graphs. Yes, what you observe. Yes, I will listen. Anybody
Madam,
not comfortable talking can text that, can chat in the chat box.
Madam, in the graph, we can see the relationship between future value factor and the time.
Yes, yes, first thing. Yes, that's the relationship that shows. Yes. Yes, what else? So you see 4 lines. 4 lines drawn according to 4 interest rates. Yes, what else do you observe? It shows the relationship between time and interest rate is first point. Yes, I accept it. Very good.
I see the future value factor and the time both are increasing. Definitely, the interest rate also increasing.
Sorry, explain it to me again, please.
No, madam, I think I did a mistake. Sorry.
Okay. Come back again with the correct meaning, please.
By using this table, we can get future value factor for different rates and time periods. For these 4 interest rate, we can get future value factor.
Yes.
In different times.
Okay.
If
okay,
R value is increasing, slope is increasing.
R value is increasing and the slope is increasing. Yes. Future value increases when time increases. Yes. An observation by one on the chat box. Yes, correct. Another, anything else? Now you can talk about different lines. There you see 4 colors, 4 lines. You can explain the lines to me.
The gradient of each line increases with the rate.
Sorry.
Gradient of each line increases with the rate.
Okay.
Madam, if future value factor is constant and the time is increasing or decreasing, the interest rate is 0.
Interest rate is 0 when?
future value factor is constant and time is changing?
Now see, look at the green line. Look at the green line. Now these 4 lines show you the relationship between the future value factor and the time, right? We have drawn it for 4 interest rates. First is the green line where interest rate is 0. You see a straight line. You see a straight line, which means it's the same value, isn't it? It's to 1.5 or something like that. Let's take it as 1.5 here, right? It's right throughout, it's 1.5 because you compound at 0 rate. You compound at 0 rate. It doesn't increase, isn't it? Future value doesn't increase. If interest rate is 0, if you compound it, now if we take it as, let me show you the formula. If you compound it, if you, where is it? Now here, if you compound it, if the interest rate is 0, what happens if we substitute 0 here? Future value at n equals present value into 1 plus 0 to the power n, right? Here 1 plus 0 makes it 1. So future value 1 equals present value 1 to the power n. It will be the same. Future value of 2 will be present value into 1 to the power 2. So 1 to any power is 1, isn't it? Right? So future value at any point will equal the present value if the interest rate is 0. Understand? Did you get it? So that is indicated by this green line. If the interest rate is 0, now here it's today, time 0. This is after 15 years. So line is straight because right throughout the value is the same if you compound it at 0 rate. Get it? Get it?
Yes, madam, got it. Can you interpret it again?
In what way? Now, see, we are talking
the
about...
interest rate is 0.
Yes.
Future value in any point will equal to present
value.
Yes. Okay.
Get it?
Yes.
Because it will not increase, right? Okay. Now, if you compare the line, see, R equals 5, the red line, is a little bit higher. Now, it has a small slant increasing throughout the time. We are compounding it at 5%. So, first 1 rupee will become 1.05 in the second year. 1.05 will be again compounded by 1.05 in the second year, right? So, it will gradually accumulate. And future value will gradually increase, right? Now 10%, you are compounding it at a higher rate. So you see a higher line. That is, this is future value, right? Future value is a little bit higher than your compounded rate at 5%, right? And you compound it at 15%. You see a much higher line. The future values are very much higher compared to 10%, right? So if you compare these now, see, these are not, the differences are increasing. The difference between the lines are increasing. Why isn't the difference similar? Why is the difference increasing? Can anyone tell me an explanation for that, please? See, at the 5-year point, you see very small difference between the lines. At 10 years, you see that the difference is a little bit increased. At 15 years, you see that the difference is further increasing. Any idea? Yes. It's the amount of interest on interest that is making this exponential change, right? So this is the nature. Now, say I show you it in a graph. With time, future value increases. If interest rate is 0, future value will not change. If lower interest rates, lower will be the increase in future value. Higher interest rate, higher will be the future value with time. right? With time, the difference will grow larger with time. The difference in the future values will grow larger with time because mainly due to the interest on interest. Understand? Is it clear, everyone? Anyone wants to ask a question on that? Yes or no?
It was clear, madam.
Okay, thank you very much. Yes. More frequent compounding, right? Now we were talking about, yeah, thank you very much. We were talking about annual compounding, right? Annual compounding. But compounding can take place more than once within a year also, right? We call it more frequent compounding. Interest may be compounded more than once a year, right? So the nominal rate or the annual percentage rate in our example, we took it as 10%. Is the periodic rate, right? Times the number of periods per year at 10% for 5 years, right? Is the nominal rate, right? But when you compound it within the year, say for example, you compound it twice a year, right? Then what happens? During the first 6 months, you accumulate interest and for the second half, you have to calculate interest on interest. So if you calculate the interest rate, it will be higher than the nominal rate, So we call it effective annual rate, right? Or you call it annual percentage yield, APY, right? Is the true annually compounded interest rate, right? So let's take an example and see so that it will be clear for you all, right? So comparing rates with different compounding frequencies. When the compounding frequency is different, example, Bank A compound interest annually and Bank B does quarterly. So comparison should be made on the APY or the effective annual rate. Now, if you are to compare, now why we learn these things is to facilitate us in decision making, right? So if we are to compare two investments where compounding frequencies are different, right? Say I have one investment, if I put 1,000 rupees, they will give me 10% on an annual rate, and after 5 years, I can get the amount. And there is another investment, I invest 1,000 rupees, they pay me annual interest rate for 5 years, but they compound it on a half yearly basis. I think you can remember some banks offer to calculate daily interest rates, right? They calculate your interest on a daily basis and edit your balance, right? So then in that case, you cannot just compare the nominal interest rates and then decide on which investment is better. Right? In a case like that, if you have to compare two investments where the compounding frequencies are different, you have to look at the APY, annual percentage yield, or the effective interest rate, in order to compare the investments, in order to choose the best investment for you based on interest rate, right? So, okay, so let's do this exercise. Effect of compounding frequency on future value and effective annual rate, right? Find the future value at the end of 1 year. If the present value is 20,000 and the interest rate is 16%, use the following compounding frequencies. So we have a present value or an initial investment of 20,000. Interest rate is given as 16%, right? Then if it is annual compounding, which means you compound it once a year. Semi-annual compounding, which means you compound it twice a year. Quarterly compounding, which means you compound it 4 times a year. Monthly compounding, which means you compound it 12 times a year. Daily compounding, which means you compound it 365 times a year. Continuous compounding is you do it continuously, right? So if these are the cases how are we to calculate the future value for 1 year period, future value plus the interest rate, right? Plus the effective interest rate, right? So I will show you the first one so that you can follow that with the others, right? The periodic rate is 16%. So if it is annual compounding after 1 year, future value after 1 year, future value 1 will equal to, now our initial investment is 20,000. Annually periodic interest rate is 16%. So we multiply it by 1.16 to the power 1 because we are keeping it only 1 year. So our future value will be 23,200. So our effective or annual percentage yield and the nominal percentage rate is equal to 16%, right? Now we make a small adjustment in the formula if we are compounding it more than once a year, right? So if you can remember, this is our common formula, future value equals present value into 1 plus r to the power n, right? That is our common formula. So we make an adjustment to that. What is the adjustment? Now here, earlier it was 1 plus r. What we do is we divide r by m and multiply n by m. M is the number of times the sum is compounded within the year, right? M is the number of times that we compound the amount within the year, right? So R divided by 2, multiply n by 2, which means you are compounding it twice a year. R divided by 4, multiply n by 4, which means you are compounding it 4 times a year. R divided by 12, n multiplied by 12, which means you are compounding it 12 times a year. R divided by 365, n multiplied by 365, which means you are compounding it 365 times a year, right? So this is how you calculate the future value. Now, n is 1 year. We are considering investment in 1 year, right? Investment in 1 year. So, shall we calculate it for the same example? Shall we, now annual compounding we have already done. And we know what adjustment has to be made to the common formula in order to incorporate more frequent compounding, right? M is the number of times that you compound within the year. N is 1 here because we are investing it for 1 year. So N multiplied by the number of times. So shall we just go through until continuous compounding, semi-annual, quarterly, monthly, and daily? Shall we do it very quickly? Yes, please give it a try. Can you put your answers to the chat, please? Yes. Okay. Semi-annual, monthly, daily. Thank you very much. I received one answer. Okay. Okay. Thank you very much. Yes. Okay. Shall we check the answers? Let's check the answers. I think most of you have done by now, right? So let's check. If M is equals to 2, semi-annual compounding, the periodic rate becomes 8%, right? So we divide 16 by 2 and multiply n, which is 1 by 2, right? So it becomes after 1 year, future value after 1 year, 20,000 into 1 plus 0.16 divided by 2 becomes 0.08 to the power 2. The future value becomes 23,000, 23,000. What is that? I'm sorry. And 2. I know there is a small mistake in the figures. 23,2328, right? Yes. That's in sense also. Yeah, that's fine. Now, in that case, we can now earlier, if it is annual compounding, APY equal to NPR, right? APR. Yes, yes, thank you. 23,328. Yes, thank you very much. Yes. 1, 2 is, there is an excess letter here, figure here. That's the problem. Yeah, I'm sorry. Sorry, I cannot correct it. Yes. Yes, thank you. Right. So now we can calculate the annual percentage yield, right? It's the 1 plus 0.16 divided by 2 to the power 2 minus 1 will give you the annual percentage yield or the effective rate, right? Annual percentage yield or the effective rate, that is 1 plus R divided by M to the power M into N minus 1 will give you the effective rate, right? The effective rate. So For semi-annual compounding, 1 plus 0.16 divided by 2 becomes 1 plus 0.08 to the power 2 minus 1 is equals to 0.1664, or you multiply it by 100, you get 16.64, right? So nominal rate is 16%. Now here APY on semi-annual compounding, or the effective rate on semi-annual compounding, has become 16.64, right? So which is greater than the nominal rate. It is due to this 8% interest being calculated for half year on 20,000, right? Say for example, we did the investment in 1st of January. How R becomes 2? R becomes 2. What is R? Here, R becomes 2. What is R? I'm sure.
No, madam, they are to the power 2.
A power 2 is now, see, here it's M into N. This is an adjustment that we do to the formula. To accommodate more frequent compounding, right? Our common formula was future value of N equals present value into 1 plus R to the power N. It was our common formula. This was our common formula. Future value of N equals present value into 1 plus R to the N. So N is the time period, R is the nominal rate. We do only annual compounding. But if we are doing semi-annual or quarterly or monthly compounding, we said we have to make an adjustment to the common formula. The adjustment is you divide R by the number of times compounded within the year. If it is semi-annual, you divide it by 2 and multiply N by 2. Right? That is N into M. Right? Multiply N by 2 and divide R by 2. If it is 4 times, you divide R by 4 and multiply N by 4. If it is 12 times, you divide R by 12, multiply N by 12. Understand? Get it?
Yeah.
NPR is nominal percentage rate. Is the annual rate. If we are compounding it on an annual basis, the interest rate that is applicable is called the nominal percentage rate. Right? So effective rate is if we are compounding it within the year, what happens is the nominal is not the one that is applicable, because in the interest on interest, our effective rate becomes larger. Right? So where were we here? Here, right? So did you get why we divide it by 2 and take it to the power 2? Yes, please. The person who asked.
Yes, madam, we good.
Yes, madam.
Okay. Right. So APY, or annual percentage yield, becomes 16.64%, which is greater than the nominal percentage rate. This is due to the half year's interest rate that we add at 8% on 20,000 until June. Say, for example, we may start the investment in January, we go until 30th June. So we calculate 8% interest on 20,000, and on that we calculate plus the interest rate, we calculate the balance half year interest, right? So that is why the interest rate has become greater than percentage rate, right? So we go on to, you can check your answers while we go on discussing. If it is quarterly compounding, since M is equals to 4, the periodic rate becomes 4, because 16 divided by 4, now it's N is 1, 1 multiplied by M, which is 4, gives it to the power 4, right? So 20,000 is invested. After 1 year, we compound it 4 times a year. So we divide interest rate by 4 and multiply N by 4. N here is 1, multiplied by 4 gives it to the power 4. So it becomes 23,397 and 17 cents. right? And we can calculate the APY, or the effective annual rate, or the annual percentage yield, right? That is 1 plus 0.16 divided by 4 to the power 4 minus 1, which is 0.16986. Or if we consider it as a percentage by multiplying it by 100, it becomes 16.986, which we see is greater than the nominal percentage rate, and it's greater than the APY of semi-annual compounding rate, right? Semi-annual compounding rate was 16.64. If it is quarterly, it has become 16.984, right? Then, yes, so quarterly, monthly. Monthly, if you divide it by 12, it becomes 23,445 and 42 cents, and APY has become 17.227, right? I hope you have done the calculation. If it is daily, you divide 16% by 365 and you take into the power 365. So your future value becomes 23,469 cents. APY has become 17.347%. So now if you look at the table, right, now what can you observe? You can observe that on the left-hand side you have the compounding frequency, annual, semi-annual, and on the middle line you have M, that is number of times compounded in the year. And in the third column you have future value, and in the last column you have the effective rate, annual percentage yield. So what are your observations? Just give me your observations, please. What are your observations on this calculation? Yes. Yes.
Increase in the frequency, annual percentage yield also increase.
Yes. Yes. When the compounding frequency increases, the annual percentage yield or the effective rate increases. That is one observation. And similarly, you see when the compounding frequency increases, even the future value increases, isn't it? Future value increases. So number of times compounded within the year increases, results in an increased future value. Increased future value. This is mainly because of the interest on interest, right? Because the capital doesn't change, interest will be added in between at intervals so that it will carry interest on interest, right? So higher the frequency, higher will be the future value. Higher the frequency, higher will be the annual percentage yield. So we have come up, so we have done up daily. What happens formula when you go for continuous frequency, right? Continuous.
Madam, excuse me. Your voice is breaking, madam.
What am I supposed to do for that? Not clear.
Yes, madam, sometimes.
Okay. Is it the internet connection, quality of the internet? Is it, or is there something wrong with my voice?
I think you have enough waves, madam.
Okay.
But
yeah, I'm sure I'm shaking my head. That's the problem. Okay. Thank you very much. Yes,
welcome,
thank you
madam.
very much. Maybe I'm taking my mouth away from the. Yeah. Can I repeat? Can I repeat, please?
Excuse me, madam.
Yes.
That
Yes.
early question. There is one more. Is it? Can you go to the question slide?
Yes. Yes. Question slide. What is it? Yeah. Yeah.
That one. What? That one, madam. What do you mean as continuous compound?
Yeah. We are trying to learn that now.
Okay, madam. Okay.
Okay. So do you want me to repeat the unclear parts? Do you want me to repeat the explanation here?
Okay, madam.
No, madam, it's clear.
It's okay. Thank you very much. So we move on to continuous compounding. Right? With continuous compounding, M becomes very large. Now, M, semi-annual, M is 2. Quarterly, M is 4. Monthly, M is 12. Daily, M is 365. Now, if it is larger than that, it happens continuously. In every second, it becomes, right? It is compounding. So, M becomes very large. You call it continuous compounding. Right? When M becomes very large, let's see what happens to the formula. Our formula is future value of N equals present value into 1 plus R divided by M to the power M into N, right? Now, as M approaches infinity, it's huge. It's a huge number that it is closer to infinity, right? The value of 1 plus R over M to the Mn goes to ERN, right? So I don't talk about the mathematics in this, right? Only thing is we have to remember the revised formula, right? Revised formula, because now R is divided by a huge figure and N is multiplied by a huge figure, right? It's as huge as infinity. We cannot quantify it, right? It happens very frequently, so that we lose count of the times, right? So it's close to infinity. So it becomes, now this part becomes ERN, right? ERN, E to the power RN. So we substitute instead of this E to the power ERN to the formula, right? Then the effective rate equals ER minus 1, where E is 2.71828. So E is a constant, right? E is a constant. E is a constant. So it becomes E 2.71828 to the power R into N, right? To the power R into N. So thus the effective rate becomes, right, 2.71828 to the power, now in R is 16, N is 1. So it is 16% minus 1. So when you simplify it, you get 0.17351, or if you express it as a percentage, it becomes 17.351. So if we are to calculate the future value after 1 year on continuous compounding, you can apply this here. Future value equals 20,000 into 1.17351 to the power 1, because N is 1, equals 23,469. So if you go back to the table and compare it, right, I think it's almost close to the daily compounding. Like say, it's a little bit higher than the daily compounding. This 23,469, right? Right. So continuous compounding, where M is an uncountable number, a huge number. So it becomes, this goes to ERN. E is a constant. I'm sure you have learned this in your basic mathematics somewhere in grade 10 or 11, right? So we can apply this figure and the relevant data, calculate the effective rate if it is on continuous compounding, right?
Madam, without finding effective rate, can't we apply this if V n equal PV E R E power R rate? Can we use this equation to calculate future directly?
Sorry, you mean without using this, can't we use this, is it?
Yes, madam.
We can use it if it is only on continuous compounding.
All right, okay. I am asking, madam, without finding effective rate,
Yes.
here, can't we use this formula, second formula?
Yes, you can.
Okay.
You can. To put to a PV here,
Yes.
E is 2.71828, R is 16, N is 1. So E
equal to 2.718 and 0.16 and N is 1.
Yes.
Right, madam. Okay, thank you.
Okay. Right. So
Question, madam?
yes. Yes, please.
Yeah, in this example, how can you decide N equal 1?
Because at the very beginning in the exercise, I go back to the exercise. In the exercise, we said find the future value at the end of 1 year. End of 1 year. See, that is why we decide it's 1.
Okay, madam. Okay.
So for example, if I said end of 2 years, we make n into 2. Okay.
Okay.
Yeah. Okay. Yes, present value. Now, all this time we were talking about the future value. We know the present value of the amount of money, and we are trying to focus what the value of it after, say, 1 year, 10 years, or whatever, with different intervals in compounding. Right now, we are in, say, for example, we know the future value. We know the future value of a sum of money, and we want to know what the value of it at the present time, right? Then we can easily use the rearrange the formula that we learned for future value, right? This is the common formula that we learned. Future value equals present value into 1 plus r to the power n is the common formula. Now we can rearrange it to solve for present value, right? Rearrange it to solve for present value. You take present value to the left-hand side of the equation and you put future value to the right-hand side of the equation, right? Or say, you keep present value at the right-hand side and you bring 1 plus r to the power n to the left-hand side of the equation. So the multiplication will become a division when you change the side of the equation, right? So present value becomes future value into 1 over 1 plus r to the power n, or else future value divided by 1 plus r to the power n will give you the present value of a future sum of money, right? So are we having a break in this class?
Yes, madam. Normally around 10, we are getting a 1.
Yes, at 10 to 10:30, is it?
Yes, madam. Sometimes we are getting 20, 30, likewise. The maximum is 30 minutes, madam.
Maximum is 30. So how long do you want to have the break today?
How do you feel, madam?
It's up to you, because I mean, I'm not sure whether you are with breakfast, without breakfast. Just woke up, I don't know. In my case, it's okay.
Is it okay to have 30 minutes break, madam?
Of course, we'll have now from it's 9:55. Let's stop at 10, start at 10:30, and then go for another 1.5 hours.
Okay, madam. Thank
Then we
you.
cover 3 hours.
Okay, madam.
Won't be a problem, right? Okay,
Yes.
thank you very much. So let me start on this, and then we'll break for tea. So future value formula is this. This is the common formula that we learned today, right? Future value equals present value into 1 plus r to the power n. So we rearrange this equation to solve for present value. So you take 1 plus r to the power n to the left-hand side of the equation, where it becomes a division, right? Future value of n divided by 1 plus r to the power n, or you can state it as a multiplication, future value of n multiplied by 1 over 1 plus r to the power n, right? So when we get the present value, the interest rate is referred to as the discount rate. And this process is called discounting, right? So earlier in the future value calculations, we call it interest rate, and the process was compounding. And now it is the discount rate, and the process is called discounting, right? Process is yeah. So what is the present value of 100 due in 3 years if the discount rate is 10%? What is the present value of 100 due in 3 years? Now, in 3 years, we are supposed to receive 100 rupees. So, what will be today's value of this 100 rupees if the discount rate is 10%, right? So, finding present value is discounting, and it's the reverse of compounding. So, shall we just give it a try before the tea break? So, it's the future value is 100 interest rate is 10%, right? And N is 3. 3 years we receive it, right? So let's find the formula. Now present value equals future value divided by 1 plus r to the power n, right? 1 plus r to the power n, So which means, sorry, it means future value is 100. This is the amount of money that we will receive after 3 years. You divide it by 1 plus 0.10 to the power 3. So what is the answer? We'll have 1 point. Let me check with my phone. We have 1.10, sorry. 1.10 to the power 3. The power 3 gives me 1.331. So 1.331, I have to divide 100 by 1.331 equals how much? 100 divided by 1.331 is 75 rupees and 13 cents. Did you all get it, please?
Yes, madam. We also got the same answer.
Okay, that's great. So shall we break for tea then?
Madam, small question.
Yes.
In the continuous compounding and daily compounding, the answers are exactly same. Is there any relationship between them?
Now, continuous or it's going for a long time period. Then it after, like say, after a long time period, the amount of increment is very small. The addition is very small. Now, if you calculate the annuity for 100 years and a perpetuity, the present values will be very similar. It's because when time passes, now see, time passes plus we convert it to today's value. So the increment becomes very small. Because see, it will be there added interest only for a second, since it's happening continuously. Get it? Did I answer your question or no? Did I answer it?
Madam, can you kindly repeat this?
Yeah, now when now see, daily is you divide it by 365, right? Now every day the capital is being added to interest is being added to the capital and then compounded, and then again to that interest is being added and then compounded, right? Now when the interval is very small, the amount being added as interest is become very small. See, now, if it is semi-annual compounding, we have 6 months interest.
Madam, you are not audible, madam.
Oh, sorry. So, now if we are taking 6 months, if it is happening semi-annually, we add 6 months interest to the capital, and then on that we calculate the interest or the total value for the second half, right? If we are doing it quarterly, we are doing it on a quarterly basis. The intervals are small, right? And you are doing it daily, you do it on a daily basis. So interval is very much small, right? So when the interval becomes very small, the amount of interest that is added becomes very small. So when your calculator rounds off figures, it gives you almost the same number. Maybe the difference is in cents. Did I make sense in that?
Yes, madam. Thank you.
Okay. Right. So I'll see you at 10:30. Is everyone back?
Yes, please.
Yes, please unmute yourselves. Cannot? Yeah, let me. Participants. I think now it's okay. Is it okay now?
Yes, madam. Now we can speak.
Okay, because I muted because there were some noises like say during speak. So it's for privacy, so I muted all. I'm sorry. Yeah. So shall we start? Okay. Right. So present value of a future 100 rupees that we would receive in 3 years' time. The discount rate is 10%. Today's value will be rupees 75 and 13 cents, right? So do you all see the screen? No. Thank you very much. Yes. So this is the present value interest factor table, right? Just like the future value, you can calculate present value using the table or using the calculator or using an Excel spreadsheet, right? So this is the similar thing that you saw for future value. And the only difference is now we are using the present value interest factor. Earlier, we used the future value interest factor. Future value interest factor was 1 plus r to the power n. Now, present value interest factor is 1 over 1 plus r to the power n. Now, this is 10%. So, what are your observations on this? Like in the earlier one, I would like you to comment on the table. I have done that already. Yeah, I have, yeah. I have, yeah. Okay, now? Are you all okay?
Now okay, madam.
I'm sorry. Okay, right. Okay, now yes, let's see what you can see from this present value interest factor. Yes.
Madam, with the passage of time, both are decreasing.
Yes. Yes. The longer the time period, the lesser will be the present value. Right? So if you receive 100 rupees in 3 years' time, you'll have a present value, and it will be less if you receive it in 5 years' time. And it will be much less if you receive it in 10 years' time. Right? So with the passage of time, lesser will be the present value, right? So calculation, you don't have any problem, I guess. 1 over 1, 1 plus 1, this is 10%, 1 plus 1 to the power 0. Anything to the power 0 is 1. So 1 over 1, it becomes 1, right? So present value of 1 is 1. Then after 1 year, it becomes 0.909. After 2 years, it becomes 826. So like in the earlier case, if I ask you now, if it was 10, our earlier example, after 3 years, we receive 100 rupees after 3 years and the interest rate is 10%. So we can read it from the table, right? 100 multiplied by 0.75131 will give us the answer, right? That was the answer, 75 and 13. So you can use this table. Like the future value tables, present value tables are also available in at the back of textbooks, right? So we can use it easy. Right. Then we have the same graph the other way around. Yes. For your comments, please. Yes. Yes.
So value, madam, is decreasing with the increasing of time.
Yes, present value is decreasing with the increase of time. Yes.
Yeah, if the interest rate is 0, it will remain as it is.
Same. Yes, same. Like the green line. Yes.
Then, and apart from that, if the highest interest rate, the present value, the level of present value is the lowest.
Yes. Higher the interest rate, lower will be the present value. Longer the time period, lower will be the present value. Interest rate is 0, present value will not change. Right. So it's the reverse of the future value. So we saw period compounded, higher will be the future value. Higher the interest rate, higher will be the future value. Okay? And in the present value concept, the longer the time period, lower will be the present value. Higher the discount rate, lower will be the present value. Okay? I hope everybody could get it. Right. Now, yes, we have some examples. Shall we try working these? What is the present value of rupees 1,000 to be received 15 years from now if your opportunity cost is 7%? Opportunity cost is the discount rate or the interest rate or the time value of money. Right? So what is the present value of 1,000 to be received 15 years from now if your opportunity cost is 10%? Shall we give it? Yes. Yeah, thank you for the answer. So we have how much? Present value of 1,000 to be received in 15 years. So this is future value. 1,000 is future value. N is 15 years. N is 15 years. R is how much? 7%.
7.
Yes. R is 7%. Right. So we have future value equals present value divided by multiplied by 1 plus r to the power n. So since we are calculating the present value, let's take present value equals future value divided by 1 plus r to the power n So it will be, now future value is 1,000 rupees divided by 1.1 0.07 to the power 15. Yes. What is the answer, please?
362.446.
352.
362.446.
Oh, sorry, 362. Okay, did everyone get that?
Yes, madam.
Okay. Okay, well, let's go to the second one. If you sold a land for rupees 11,933 that you bought 5 years ago for 5,000, what is your annual rate of return? Now, all this time, we were given all the information except for one, right? So, what is the present value? And we were given the future value, interest rate, and the time period, right? We were supposed to find either the present value or the future value. Now, in this exercise, we are given, yes, thank you. Yeah, thanks. Sorry, I'll try my best to do that. I will try my best to do that. Yes, thank you for the request. So here we are given the future value and the present value, right? And we are supposed to find what is the annual rate of return. Yes, shall we give it a try? So let's try to do it. We have future value. Sorry. We have future value is equals to 11,933. 933. Present value is 5,000 rupees. And what is 5 years ago? N is equals to 5. N is equals to 5. So we have future value equals present value into 1 plus 1 plus r to the power n, right? So we substitute figures. Future value is 11,933 equals 5,000 into 1 plus r to the power 5, right? So what we can do is here take 11,933 divided by 5,000. You take 5,000 to the left hand side of the equation, and then you are left with 1 plus r to the power 5. So what you can do is to get rid of this power, you can multiply both. You can take the power 1 over 5 on both sides, right? It is, you have 11,933 divided by 5,000. 5,000 to the power 1 over 5 equals, you take both sides, right? The same thing. 1 plus r to the power, now we already have power 5. You multiply it by you multiply it by 1/5. So this get cancels off, it becomes 1. So 1 plus R equals, and you can have 1 plus R equals 1 plus R equals 11,933 divided by 5,000 to the power 1/5, and then you can simplify it and then solve for R, right? -1 will give you how much? What is the rate?
19%.
Okay, R equals 19. Yes, thank you very much. Right? I hope everybody could understand that. Right? And then we go to the next example. If everybody get it clear. Suppose you placed 100 in an account that pays 9.6% interest compounded monthly. How long will it take for your account to grow to 500? Yes, thank you for all the correct answers. I get 6.72. Where did you make that mistake? One answer.
It's a calculation mistake, madam.
Okay. Okay. Yes. So let's take the other one. Yes. Yes. What is it? Suppose you placed 100 in an account that pays 9.6% interest compounded monthly. How long will it take for your account to grow to 500? So we have future value 500 R equals 9.6, 9.6, and yes, present value is 100, isn't it? So how long will it take? So we can have the formula future value equals present value multiplied by, now here it's on a monthly basis, so we have to divide R by, R is 0.096, isn't it? R divided by M, that is 12. R divided by M, and it has to be taken to the power N into M. N into M, right? Okay. So future value is 500 equals present value is 100. Then 1 plus R is 0.096. 0.096 divided by 12 into N we are supposed to find. So 12N to the power 12N, right? Now we have to solve this. First, let's take the 100 to the left-hand side of the equation, right? Equals 1 plus 0.96 divided by 12 to the power 12N, right? Now, since this is a power and we have to find N, we can take natural logarithms on both sides, right? Ln is natural logarithm. 500 divided by 100 equals, when you take logarithm of a power, it becomes a multiplication 12N ln into 1.096 divided by 12. Sorry, no, it's wrong if I say like that. Yeah, sorry. Now take the From your calculator, you can calculate the natural logarithm and get the figure. And here you can take the natural logarithm of this proportion from the calculator, and then you can solve for n, right? Divided by the answer by 12, you get it in terms of years. Leave it like that, get it in terms of months. So what is the answer, please? Two people give me the same figure and says one says years, one says months. Now what am I to take? 16.83 years or 16.83 months? Yes. Which is the correct one? Okay. 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 So did everyone get that? Okay. Now I will ask you an instant question. An instant question, right? Something that came to my mind. Instant question. Say, how long will it take? How long will it take to double your money? Money. How long will it take to double your money? If annual interest rate is 28% and compounded annually. Yes. Yeah. Can anyone give me the answer, please? Yeah. How long will it take to double your money? An annual rate, sorry, not rate. Rate is 8% and compounded annually. Yeah. Yes.
Nine years.
Yeah, let's see. Let's check. I'll wait for a few others to give answers and see. Okay. Okay. So how did we calculate? So we know. So okay, present compound. Sorry. How long will it to take double your money? So if your present value is 1, future value is 2, right? Interest rate is 8, right? So you can put it into the formula. Future value equals present value into 1.08 to the power n, right? So future value is 2, present value is 1, so you have to solve for n, right? So what if I say, if it is compounded semi-annually, if I said semi-annually, what will happen? Then we will Then we will divide this by 2 and multiply this by 2. Right? Okay, so what if we say, how long will it take to make your, say, take to your money 4 times, right? Or triple your money. Triple your money. Then your present value is 1, and how long will it take for your future value to become 3? Right? Okay. So if it is quarterly, you divide it by 4 and multiply n by 4. So if it is compounded monthly, you divide it by 12 and multiply n by 12 and then solve. Okay? Yes. 3.35 years. Yes, semi-annual 8.83 years. Thank you very much. Yes. Okay. Yeah. So we can move. Yeah. Now, so we discussed on present value calculation and future value calculation of a single sum of money. And now we move on to multiple cash flows. I said we identify 3 types of cash flows in a business. One is a single cash flow, second is multiple uneven cash flow, and the third is annuities, right? Or similar cash flows. Present value of a multiple cash flow equals the sum of the present values of the individual cash flows. So if the cash flow consists of multiple uneven cash flows, these multiple different values of cash flows, what we do is we discount or compound each and every cash flow separately and then add those together. Right? Present value of a multiple cash flow equals sum of the present values of the individual cash flows, sum of the present values of the individual cash flows. So we calculate the individual cash flows, present values or future values separately, and then add them together. So future value of multiple cash flows at a common point in time equals the sum of the future values of the individual cash flows, the sum of the individual future values of the individual cash flows at that point in time, right? At that point in time. So uneven cash flows, we are talking about future value. So initial investment at time 0 or today is 10,000. After that, as a result of this investment, you receive after 1 year 2,000, after 2 years 4,000, after 3 years 6,000, and after 4 years 7,000. How do we find the future value of a cash flow stream when cash flows are different? Use a 10% interest rate. Yes, shall we give it a try? What are we supposed to do? Future value, calculate future values separately and then add them together. So let's calculate the future value at the end of the 7th year. So 4th year, at the end of the 4th year. Shall we calculate the future values as at the end of the 4th year? Right. So 7,000 is in its normal value. So we do not have to change it. But 6,000 has to be compounded for 1 year. 4,000 has to be compounded for 2 years. 2,000 has to be compounded for 3 years. And this 10,000 has to be compounded for 4 years. And it's a negative value. If we can adjust for pluses and minuses, then we can have a net present value. Right? So shall we do it very quickly? So we will calculate each cash flow separately. 7,000, we are not going to do anything because 7,000 is in its real value because we receive it at the end of the 4th year. 6,000 we receive at the end of the 3rd year. So we are converting it by compounding it for 1 year. We are converting it into the value of the value at the end of the fourth year. 4,000, we are compounding it by 2 years and converting it to the value at the end of the fourth year. 2,000, which is received at the end of the first year, has to be compounded for 3 years to be converted to the value of, thank you very much, yes, value of the value at the end of the fourth year. So 10,000 we invest today has to be compounded for 4 years to convert it into the value at the end of the fourth year. Yes, let's do it very quickly. Please give me a I'm sorry. I'm sorry. I have not muted. I have unmuted. I haven't unmuted myself, although I have been talking. I'm sorry. Extremely sorry. Right. So this is the exercise in calculating future value. And we can calculate the future value. And if we are to calculate the present value, you take each and every cash flow to the present separately. Yes. What is the answer? What is the answer? 10,000, right? So 10,000 doesn't have to be discounted. So it's 10,000. 2,000 discounted for 1 year is 1,818. 4,000 discounted for 2 years is 3,305 and 79 cents. 6,000 discounted for 3 years is 4,507 and 89 cents. And 7,000 discounted for 4 years becomes 4,781 and 9 cents. So present value of the cash flow stream, if you add those together, get the pluses and minuses balance, you end up getting 4,412 and 95 cents. Right now, if you compound this amount, if you compound this amount at 10% for 4 years, you will get the future value. Right? You will get the future value. You compound it, future value that we got is 6,461. Present value that we got is 4,412. The relationship is the common formula that we learned today. Future value equals present value into 1 plus r to the power n, right? So present value is 4,412 and 95 cents. Compounded for 4 years at 10%, you get the future value that we have calculated, 6,461, right? So this is about multiple uneven cash flows. How to calculate the present value and future value of multiple uneven cash flows. So there is nothing new because we learned how to calculate the future value and present value of a single sum of money. And all what we have to do is apply the same principle separately to each and every cash flow and then add or deduct accordingly so that we can get the present value or the future value, right? And now we can move on to annuities. Annuity, as I told you earlier, is an identical cash flow. If you have multiple identical cash flows, we call it an annuity, right? An annuity is a series of identical cash flows. The amount is similar, not uneven. Identical cash flows that are expected to occur each period for a specified number of periods, right? So if it is for a specified number of periods, you call it an annuity. If it is for an unspecified number of long period, you call it a perpetuity, right? You call it a perpetuity, right? Thus, cash flow 1 equals cash flow 2 equals cash flow 3 equals cash flow 4 up to cash flow in, right? So whatever number of cash flows the project may have, they are all similar, right? The same amount. So in that case, we call it an annuity. Examples of annuities: installment loans, right? Say car loan, mortgages, we pay the same amount, right? So even your rent payments of your apartment, we pay the same amount, right? So, and the coupon payment of a corporate bond. So if it's a fixed coupon bond, you get the same interest rate every year. Say you get the same interest income every year. So it's in the nature of an annuity, right? So installment loans, coupon payments on corporate bonds, rent payment of your apartment are examples for annuities where you pay or receive an identical cash flow, multiple identical cash flow, right? So when it comes to annuities, depending on the time at which the annuity occurs, we can divide annuities or classify annuities into three, right? Depending on the time at which the cash flow occurs, we can classify annuities into three. What is called an ordinary annuity is an annuity with end of period cash flows beginning one period from today. So it's an annuity where the cash flow begins at the end of the year. Now, say for example, the year is starting now, the first cash flow occurs at the end of this year, right? End of period cash flows, which is called an ordinary annuity. Then what is meant by annuity due is an annuity with beginning of period cash flows. Now annuity due, now say year starts today, the first cash flow starts today itself, is called an annuity due, right? Is called an annuity due. Then the third one is called a deferred annuity. A deferred annuity is where the first cash flow doesn't occur at the beginning or at the end of the first year, right? The deferred annuity is where the cash flows occur after first year, right? Now, say for example, your father retires in 3 years' time, right? Once he retires, he will receive an equal annual pension every year, right? So that's a deferred annuity because the first cash flow doesn't occur in the first year at the beginning or at the end. It occurs after 3 years, right? So the first cash flow occurs nowhere in the first year, right? So then we call it a deferred annuity, right? Yes. Now let's look at the future value of an annuity, right? Future value of an annuity. Yes. Future value of an annuity. Say, for example, it's an equal amount of money, which is 1,000 rupees in our example. So future value of an annuity can be calculated like this. Now, say, for example, we have only 3 cash flows, right? So 1,000 first year, 1 plus r to the power 0. Second year, 1 plus r to the power, after 1 year, 1 plus r to the power 1. After 2 years, it's 1 plus r to the power 2. And at 3, it's 1 plus r to the power 3. Right? Likewise, we can calculate the future value of the cash flows, right? Since the yes, when it has n periods, then you can go on until n minus 1, right? You can go on until n minus 1 because the last one you will not calculate the future value because it's in its future value, right? So this is 1 plus r to the power 0. This is 1 plus r to the power 3. This is 1 plus r to the power 2. And this is 1 plus r to the power 1, right? So if we simplify this and we substitute this, then we can simplify it into this formula. When you substitute above variables and simplify the equation, you can arrive at this formula. Future value of an annuity equals the cash flow, that is the annual cash flow, 1 plus r to the power n minus 1 divided by r, right, is the formula. Or like in the future value and present value, for annuities also, there are tables calculated, right? Future value, interest factor, annuity tables are already calculated and you can find at the back of textbooks, right? At the back of textbooks. So multiplying the cash flow by the future value interest factor annuity is also a possibility, right? Or else you can calculate it by cash flow multiplied by 1 plus R is the interest rate, N is the time period, minus 1 divided by R, right? Yes. Future value of an annuity. If you invest 1,000 at the end of each next 3 years at 8%, how much would you have after 3 years? Yes. If you invest 1,000 at the end of each next 3 years at 8%, how much would you have after 3 years? Right? So this annuity has 1,000 rupees for the next 3 years. Interest rate is 8%, right? So cash flow is 1,000. 1 plus R. R is 8%, 1.08 to the power 3 minus 1 divided by 0.08, right? Divided by 0.08, right? So if you simplify it, you get 3,246 and 40 cents, right? Future value interest factor for annuity tables can be used to get this answer, right? So if we have 8% here, yes, 8% is given, right? 8% is given. Now you see a difference in this table. Now up to the first 4 columns, it's the same thing that we learned in the future value interest factor of the first 4 columns, right? First 4 columns are similar. We are already familiar with these 4 columns, right? The last column, future value interest factor annuity, gives the cumulative figure. Gives the cumulative figure. Say, for example, at year 1, you have 1 and future value interest factor annuity is 1. And when it becomes year 2, you have another 1,000 coming in. So 1,000 is there for 2 years, the other is there for 1 year. So you add these two together, right? 1 plus 1.08, it becomes 2.08. So when you receive a third installment, then one you have for 3 years, one you have for 2 years, and another you have for 1 year. So you add these three together, 2.08 plus 1.6640 gives you this cumulative figure as 3.2640, right? So only the last column is different. We are familiar with the first 4 columns in the future value interest factor, right? Annuity is the cumulative figure, right? So for what was our calculation? After 3 years at 8%, what will be the future value? So 3 years at 8%, it is 3.24640, right? So if you multiply it by the cash flow 1,000, you get 3,246 and 40 cents, right? So using the table is also a possibility in calculating the future value of an annuity, right? Yes. Yeah. So we have now with that simple example, we move on to the present value of an annuity, right? Present value of an annuity. It's the same as the multiple cash flow. The only difference is the amount is similar. Since the amount is similar, we can simplify the calculation, right? We can simplify the calculation, right? So first 1,000 will be discounted for 1 year. Second will be discounted for 2 years, third will be discounted for 3 years, and fourth will be discounted for 4 years. Right? So if it is an time period issue, we can go up to cash flow multiplied by 1 over 1 plus R to the power n, right? And then, like in the earlier case, we can simplify the formula, right? And when you substitute the above variables and simplify the equation, you can arrive at present value of an annuity equals cash flow into 1 minus 1 over 1 plus R to the power n divided by R, right? Or else you can, like in the earlier case in future value, you can take the present value interest factor annuity table also to do the calculation, right? To do the calculation. Present value of an annuity, right? What is the present value of 1,000 cash flow at the end of each of the next 3 years if the opportunity cost is 8%, right? So we can use the formula, right? We can use the formula. Cash flow is 1,000. 1 minus 1 over 1 plus R is 8%. N is 3 divided by R again is 0.08. So if you simplify what you get here, present value annuity factor, you get 2.5771 multiplied by 1,000, which gives you 2,577 and 10 cents, right? So this same thing can be derived from the present value interest factor table. So it again, the first 4 columns is familiar to us, present value interest factor calculation and the amount. And present value interest factor annuity is the cumulative figure, right? So if you have only one cash flow, present value factor will be 0.92593. And in the second year, you have one for 1 year, and the next for second 2 years. So you get the cumulative factor 92593 added to 8.85734, you get 1.7836. So in the third year, you get another 1,000. So you have to discount one for 3 years, the second for 2 years, and the last one for 1 year. Then you get the total of these 3, and you get the factor as 2.57710, right? So our example says 1,000 rupees at 8% for 3 years. Yes. Yes. Anyone wants to make a comment? Yes, please. Right. So 2.57710 is the factor relevant for 8% at 3 years, and you can multiply it by the cash flow, and then you get 2,577 and 10 cents, like in the calculation, right? So this is how you use the table. So these tables are already calculated and available for use, right? And then we can compare the ordinary annuity and the annuity due. Or what is an ordinary annuity? I said in an ordinary annuity, cash flows occur at the end of the year, right? Cash flows occur at the end of the year. In an annuity due, cash flows occur at the beginning of the year, right? Cash flows occur at the beginning of the year. So by making a small adjustment in the formula that we learned for ordinary annuity, we can make it suitable to be used in the annuity due, right? So we are trying to see what adjustment is necessary to convert the formula to be used, to be suitable, to be used in an annuity due calculation, right? So ordinary annuity, let's look at this one first. Ordinary annuity, first cash flow occurs at the end of the first year, second occurs at the end of the second year, third occurs at the end of the third year, right? In an annuity due, the same 3 cash flows occur at the beginning of the year. Now here it's the end of the year. Now in an annuity due, it occurs at the beginning of the year. Here it occurs at the beginning of the second year. Here it occurs at the beginning of the third year, right? Now, when you calculate the future value, let's take future value first, right? When you calculate the future value, right, let's concentrate only on the ordinary annuity, right? The payment 3 doesn't have to be changed because it's in its value, true value, right? So second one, we will compound for 1 year. This we will compound for 2 years, right? And add together, right? Okay. Now let's look at the annuity due. The last cash flow occurs here. So if we are to calculate the value at the end of the third year, the third cash flow has to be compounded for 1 year. The second cash flow has to be compounded for 2 years. And the first cash flow has to be compounded for 3 years. So if you compare the two cash flows, here the third one doesn't have to be compounded, but here it has to be compounded for 1 year. Here it has to be compounded for 1 year, but here it has to be compounded for 2 years. This has to be compounded for 2 years in this, but in this it has to be compounded for 3 years. So at every cash flow, when you take annuity due, you have to compound one more period compared to the ordinary annuity. You have to compound one more period compared to an ordinary annuity. So what we can do is take the ordinary annuity formula, multiply it by 1 plus R. So at every stage, at every year, then it is compounded by 1 more year. It is compounded by 1 more year. So this is the adjustment that we make to the ordinary annuity future value formula in order to convert it to be suitable to be used in the annuity due, right? So if you invest 1,000 at the beginning of each of the next 3 years at 8%, how much would you have at the end of year 3, right? So if you use it at the beginning of each year, of the next 3 years, at 8%, how much would you have? So all what you have to do is adjust the formula by multiplying it by 1 plus R. So if you take the table also, what you can do is multiply the future value interest factor annuity by 1 plus R, right? So if we calculate it now, 1,000 is the cash flow, 1 plus 0.08 to the power n is 3 minus 1 divided by 0.08, multiplied by 1.08, right? Multiplied by 1.08, so that we get 3,506 and 11 cents, which is the future value of an annuity due, right? Did you all understand it? Okay. So in the case of the present value, so let's look at the same story, right? In terms of present value, right? In the case of present value, what will happen? Now, let's first look at only the ordinary annuity, right? First, let's look at only the ordinary annuity. If we are to convert it into present value, what we have to do is we discount the first cash flow for 1 year, discount the second cash flow for 2 years, discount the third cash flow for 3 years, right? And add those together, right? But the same cash flows, let's see if it is an annuity due, the first one occurs at the beginning. So we do not have to discount this. Second cash flow will be discounted for 1 year. Third cash flow will be discounted for 2 years. So if you compare these two, in an ordinary annuity, you discount the first cash flow for 1 year. In annuity due, you don't do it. In the second cash flow, you discount it for 2 years. But the annuity due, you do not have to discount it for 2 years, but for 1 year less, right? The third cash flow, you have to discount it for 3 years, and here you have to discount it only for 2 years. So you see, at every stage, you are discounting 1 year less. In an annuity due, you have to discount 1 year less, right? So in order to compensate for that, right? In order to compensate for that, you multiply it by 1 plus R. So this is the discounting factor, future value interest annuity, or present value interest annuity. You multiply it by 1 plus R to reduce 1 year's discounting, right? To reduce 1 year's discounting. So what is the present value of 1,000 at the beginning of each of the next 3 years? If your opportunity cost is 8%, so it's the beginning of each year. Beginning of each year, right? So we have cash flow is 1,000 rupees. 1 minus 1 over 1 plus R is 8%. N is 3 years. And R again is 8. And you multiply it by 1.08. You end up getting 2,783 and 26 cents. So if you are using the table present value interest at annuity also, what you have to do is you multiply it by 1.08. Right? So that it is converted to a present value of an annuity due. So for two reasons, so you multiply the future value formula as well as the present value formula by 1 plus R. In both cases, by 1 plus R. In the first case, to increase the compounding. In the second case, reduce discounting. You multiply by the ordinary annuity formula by 1 plus R so that it becomes suitable to be used in an annuity due, where the cash flows occur at the beginning of each period. Right? I hope you could understand. We can move on to deferred annuity. Right? So the first cash flow in a deferred annuity is expected to occur later than T is equals to 1. Right? So as I told you, the first cash flow doesn't occur in the first year, at the beginning or at the end. So if that is the name, we call it deferred annuity. Okay, so deferred annuity. And annuity's first cash flow is expected to occur 3 years from today. There are 4 cash flows in this annuity, with each cash flow being 500 at an interest rate of 10% per year. Find the annuities. Exercise. Now, there are many ways of calculating the present value of this cash flow, present value of this annuity. Yes, please come up with different ways of calculating the present value of this deferred annuity. Yes, please. It's now your time. Yeah, please. Tell me how to calculate first. How to calculate the present value of this deferred annuity. Yes, there are more than one way. There are about 3 ways of doing it. You may find even more than that. Yes, please come out with your suggestions. Yes. Yes. Yes, I can see Prasad Damarasinghe, Ramesh Fernando, Ranatunga, Sachini, Samantha Bandara. Yeah. Shashika Kulatilaka, Shanika Kumarasinghe, Sevandi, Samantha Bandara, Upeksha. Where are you all? Vikramasinghe, Venura Pussella, Upeksha Di Silva. Yeah. Pasan Veerasinghe, Prakash Eva Madhuma. Where are you all? Yes, please speak up. Yes. Yes, please. Yes, please. How are we to calculate the present value of this deferred annuity?
Madam, can we calculate the annuity for the entire 6 years and then deduct the value for the first 2 years?
Yes, that is one way, correct. Yes, very good. Any other way? Yes. Yes, please. Yes, that is also possible. Convert each single cash flow to the present value. Yes. So far two answers. One is you assume that you receive these two cash flows also and calculate the present value of the whole annuity, and then you calculate the present value of these two annuities separately and take the difference is one way, right? And another one suggested that we can take one cash flow each at a time and then bring it to the present value and add those together. So you discount this first one for 3 years, discount the second one for 4 years, discount the fifth one for 5 years, and discount the sixth one for 6 years, and then add those together. And then there is another way, like say you go and stand here at the end of the second year. You stand here at the end of the second year, you see an ordinary annuity. If you stand here at the end of the second year, you see cash flows occurring at the end of each year, right? So you can use the normal annuity, ordinary annuity formula to calculate the value, present value at end of the second year. At this point, you stand here, when you look at the cash flow, you see an ordinary annuity, you calculate the present value at this point, right? To this point, you calculate the present value and you are away 2 years away from the present, right? And you discount it as a single sum of money, right? And you discount it as a single sum of money. Okay? Did you all get it? Either you assume that you receive these two cash flows, calculate the value of the whole cash flow, and then deduct the value of these two as an annuity, taken as an annuity, present value of an annuity, and then deduct it. Or you take each and every cash flow to the present, add those together, or else you stand here, look at it as an ordinary annuity, calculate the value here, discount it for 2 years as a single sum to bring it to today's value, right? So can anyone give me the answer for that, please? Yes. 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 Please use any of the three methods and give me the answer. Please. Okay, 1,309 and 86 cents. Did everyone get that answer? Yes, what about the others? Yes, what about the others? Yes. Yes, what about the others? Okay, so let's move to the next slide. We have about 4 examples, right? So we are just 10 minutes away from 12, right? So let's try the first one. Cash flows from an investment are expected to be 40,000 per year at the end of years 4, 5, 6, 7, and 8. If you require a 20% rate of return, what is the present value of these cash flows? So cash flows from an investment are expected to be 40,000 per year at the end of 4, 5, 6, 7, and 8 years. So this looks like a deferred annuity, isn't it? Because during the first 3 years, you do not receive anything. You receive 40,000 at the end of the 4th, 5th, 6th, 7th, and 8th. That is 5 cash flows, starting from 4th running to 8th. And if you require 20% rate of return, what is the present value of these cash flows? Yes. How shall we do it? So either you can stand at end of year 3, calculate the present value of the ordinary annuity, and then discount it at 20% for 2 years. Is a possibility, right? Or else you assume that you receive all cash flows and calculate the present value of the annuity, and then calculate the present value of the annuity for the first 3 years, and then deduct it from the earlier calculation, right? Okay, can anyone give me the answer for that? 69,227. Yes. Anyone else want to try? No? Yes. The second one, if you borrow 100,000 at 7% fixed rate for 30 years, 7% fixed rate for the, yes, thank you very much. The same answer, 69,227 and 13 cents. Yes. The second example, right? If you borrow 100,000 at 7% fixed interest rate for 30 years in order to buy a house, what will be your monthly house payment? Right now, this is an annuity. If you borrow 100,000 today, that is the present value is 100,000, fixed interest rate is 7%. Time period is 30 years, debit is N is 30, and you are supposed to pay on a monthly basis. So what you have to do is divide R by 12 and multiply 30 years by 12, right? And then you can solve for the cash flow, right? The annuity, take the annuity formula. You take the annuity formula, that is present value interest factor annuity formula. 100,000 is the present value. You are supposed to find the cash flow. 1 minus 1 over 1 plus R is 7% divided by 12 to the power n into 12, that is 30 into 12. So R again divided by R, 7% divided by 12. Right? So if you solve for cash flow, you get the monthly installment. Thank you very much. 8,058 and 64 cents. Right? So you want me to show all the workings, is it? Yes, let me. Yes, let me go to the first one. Cash flows from an investment is expected to be 40,000. Yeah. 1, 2, 3, 4, 4, 4. Yeah, 1. The first one occurs at the end of the 4th year. 4, 5, 6, 7, 8. You get 40,000 each, right? 40,000 each. So if you are to calculate the present value, what you can do is take the annuity formula, right? That is present value of annuity equals cash flow is 40,000. Cash flow is 40,000. So since it's present value, 1 minus 1 over 1 plus R. R is how much? R is 20%. 1 to the power. Now we are taking it as 1, 2, 3, 4, 5, 6, 7, 8 as 8 years, right? So to the power 8. To the power 8. Then this divided by R. R is again 0.20, right? So this is the formula, right? To calculate the present value of all the annuities. And then you can calculate present value of the annuity for cash flows that you do not receive. That is 40,000 is the cash flow, right? This is 1 minus 1 over 1 plus R to the power. Now 1, 2, 3. We don't receive 3 cash flows. We don't receive 3 cash flows. So to the power 3 divided by 0.20, right? So take the difference between the two. Now calculate the present value of this cash flow of this cash flow and then calculate the present value of this cash flow and take the difference. Deduct. Understand? This is for the first question. Okay. For the second, I will do the second also, right? For the second, what are we to do? If you borrow 100,000 at 7% fixed interest for 30 years in order to buy a house, what is your monthly house payment, right? Your present value is 100,000. R is 7%, right? And N is 30, right? So you are supposed to calculate the present value of an annuity equals cash flow into 1 minus 1 over 1, sorry, 1 over 1 plus R, 1 plus R to the power n, divided by R, right? Now this is the formula. So you can substitute figures here. Present value of annuity is 100,000 equals, we are supposed to find the monthly cash flow, right? Now this is for an annual basis. So if it is going to be on a monthly basis, we have to divide R by 12. In all places, you divide R by 12 and multiply N by 12, right? This is not so clear, I'm sorry. But yes, now it's 1 minus 1 over 1 plus, it's 7%, no? 1 plus 0.07 divided by 12 to the power 30 into 12. 30. Okay. And then divide this by right? Now you simplify this, you get the answer for this one, cash flow. You can solve for cash flow, right? Okay. So this is how you do the second one, right? Okay, so shall we have the answer? Okay. Okay. So we'll have the third and fourth discussed, I think, next day, right? 12 o'clock. And there are disturbances from your side, right? I will stop at this point. Okay.
Thank you, madam.
Okay, thank you very much.
Thank you, madam.
Thank you, madam. Thank you. Have a good day.